Page 9. Postulate is a word you're going to see a lot. Nope. It's a rule. Accepted without proof. And the same thing goes for an axiom, okay? A postulate and an axiom are rules that we just accept. We don't prove that they're true, we just accept them. Okay? Math is complicated. Okay. Not really. So we are going to talk about what a coordinate is, distance, and congruent segments.
I'm just gonna underline.
Okay, so when we talk about a coordinate, and right now in this lesson, we're just going to talk about one dimension for a moment. Okay, a coordinate is a real number that corresponds to a point. Zach, I have a coordinate at 5 and I have a coordinate at 17. If I wanted to find the difference between those two, what would I, or excuse me, the distance between those two, what would I need to do? Okay, now what if I have a coordinate at like -5 and, okay, subtract, right? We're gonna go with that. If I want the distance between two coordinates, we're gonna subtract. Now, can distance be negative? No. Okay. So we're gonna talk about, is there a way to like make a number always positive?
Absolute value.
Wait, that was like the 2 lines. Put it, right?
Yep.
Where, wait, that's just like how far away it is.
From 0, yeah.
Yep. Okay. Okay. So, I mean, really, guys, did we have to like officially talk about that? Probably not, but geometry is a lot about vocabulary. So we're just going to formally define some things. Now, a word that you're going to see a lot in geometry is the word congruent. It's a funny word, and it has a really fun symbol that I really like, and we'll get there in a moment. But congruent, raise your hand if you think you know what congruent is going to mean. Keegan. Yeah, like the same size. Okay. So congruent segments, what's going to be the same size? Okay. Line segments. Line segments that are the same length.
That's a line segment.
Well, a segment is a line segment. It is a postulate. We have to accept it. That's okay. Okay. All right. So I want to talk about congruent segments a little bit more. So we are going to go to page 10 and we're going to look at that. Okay. So let's look at page 10 and I want you to have your highlighter. Okay. So we just talked about what congruent segments mean. Segments of the same length. The first thing that I want to point out is the notation. Do you see that little tick mark? Okay. No. These tick marks are like, hey, this segment is the same length as this segment. It's not dividing it in half. It's a symbol notating this segment is the same as this segment.
Would have been better if they didn't make it the exact same.
Okay. Now, there's two ways to notate it. Okay. Since congruent segments means our segment length is the same, we could say that the measure of AB is equal to the measure of CD. Okay. Or if we talk about the segment, here's our fun symbol, congruent, equals with a wiggly above it. That means congruent. Congruent. Ask me what?
Not you.
Then we don't need to be worried about asking anybody else anything.
Oh, sorry.
Like kind of.
That kind of equals is 2 of the squigglies. Okay. So let's practice drawing something here. I would like you to draw this. ABC. And right below it, we're going to draw the same size DEF. Draw it, don't talk. Band class was this morning. All right. We could say, so I'm telling you this. Ready? Make this mark. Boom, boom. I just told you that AB with the segment above it is congruent to DE. Ben.
What if the line was in between E and F on the bottom? Would it still be?
Well, then AB would be congruent to EF.
Okay, but it'd still be, even if it's not on the graph, like right above it. Still
Yeah, here. Like that.
Okay.
Okay. Now, watch this. If there are more than one pairs of segments, we're going to have to use a different notation. So now I've made these double marks to symbolize that BC is congruent to EF. If they all had just one little tick mark, they all 4 would be congruent. Okay. 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 When we talk about the line segment, we're going to use the congruent. When we talk about the measure, we don't have these top pieces, right? We only have AB equals CD. We don't have the segment on top and we don't have the squiggly. Okay. So that would be like if AB was equal to 4, that's a measure. We have like a number attached to it. Okay. So when it's a number, when it's a measure, we don't use the line segment and we don't use the squiggly. If we're just talking about the segment in general, we have to say that it's a segment and we have to use the congruent symbol. All right. Here's where we're going to have some fun with numbers. With your highlighter, the segment addition postulate. So postulate is that word. Okay. We're just accepting that it's true. Okay. If we have three collinear points, and one of those points is in between the other 2, then what we can do is we can take segment AB, right here. We can add its measure to the measure of segment BC. And when we add them together, we get the total measure of AC. I mean, that seems reasonable, right? Answer. Because when we name a segment, we name the two endpoints. So since it starts at A and it ends at C, we call it AC. Let's draw a picture. Okay, I am telling you that the measure of AB is 5 and the measure of BC is 7. If I want the measure of AC, who said 12? Tyler, why? Oh, Adri, why 12? Yeah, it's that simple because 5 plus 7 equals 12. Done.
I remember this once too.
I mean, you can add numbers together, yeah, but you never did geometry lesson. Okay, I'm gonna kind of skip around. So here we go. We are gonna do a similar problem, but with some algebra. So I think you might need your notebooks to do some of these examples in. I'm not sure you can squish them all in your journal. So in your notebook, please draw this RST. Your notebook. This is not in your journal anymore. And it is my fault. I didn't ever tell you to have your notebooks out. Sorry. So wherever you put your examples yesterday when we did notes, let's just like continue on, all right? So I would like you to draw RST, please. Okay, now here we go. I hear somebody who thinks they know the answer. If you only write x equals 12, I'm not going to accept it. Okay, this is the work that I would expect to see. Now, this you wouldn't necessarily have to do, okay? This is just like me like drawing on my picture. But I need to at least see that you set up x plus 17 equals 29 because that's our ruler postulate. Or our segment addition postulate. So yeah, x equals 12, but Jake Jensen, if you only have x equals 12, I'm not gonna be happy. I need to see that you wrote this down. Okay. Now I'm picking on Jake because I saw that he didn't show his work one time already this year. He is not the only one, Ben Adler.
What? Just kidding.
Everybody shows their work. Intelligence level or not.
I don't have a high intelligence level.
Okay. Next example. Don't worry about writing any of this down. This is just more like for me. All right. What I want you to do is I want you to draw this right here and then stop. Just draw the number line where A, B, and you know what I would do? I would just label that A was at -6 and then B was at -1 and C is at 2. Like you don't have to label all of the tick marks. Do you see what I'm saying? No, you can't.
Oh, I know what you understand.
Like you don't have to write these down.
Do I have to draw the tick marks though, but I don't have to label them?
Yeah.
Okay. Is geometry gonna be a lot of drawing?
Yep. I don't require you to be good at drawing. I just require you to do it. Okay, so if I ask you for the distance between points, I'm sure it wasn't your fault.
That was you, right?
If it was anybody's fault, it was not Rhett's. I know. I think it was already like that, and Rhett just picked it up. Okay. All right, so let's check. Okay. Bryce, if I asked you for the measure of segment AC, what would you tell me? 8. How'd you get 8? That's how far away they are from each other. Okay. You could always take the end and subtract the beginning, and you get 8.
Wait, do we have to like write? Is that like how to show your work?
That would be how to show your work. This is probably the time where I'm totally okay with you just writing 8. Okay? Is that disappointing?
No, that's good.
That's disappointing? Well, just listen to the ones that I want work. Yes. No. Because if they were both negative, it wouldn't work like that. Because we have to subtract the 2. Okay. So like if like BA right here, we need to take -1 minus -6 to get 5. Okay, but if we separated them with the absolute value, it wouldn't work the same. Okay, yes,
BA are actually, those are actually my initials, so.
I think we all knew that. Thank you though. Okay. RO, what is the length of segment BD? What? Yep, 6. Everybody, oh, Tyler. Do you agree with Tyler?
Yes. Wait, what?
Okay.
I agree with everything.
Okay. Now, this last example, I think it's going to be to our best benefit for you to just put down your pencils. Dropping and putting down are two totally different things. Oh, whoops. Oh, well. I want to know if JK is congruent to LM. All right. So if J is -3, 4, and K is 2, 4. All right. L is 1, 3, and M is 1, -2. If I want to prove whether these two are congruent or not, what do I need to show? Raise your hand. RO. Their lengths need to be the same. How do we determine the length of JK? Raise your hand, Tyler.
Figure out like the difference between 0.
Well, you can count, or you can take the difference in the X coordinates. The Y's are the same, so that's not going to help. Okay. So JK has a measure of what, Tyler? Okay. LM has a measure of what, Cohen? So JK is congruent to LM. Tyler.
Is this still congruent even though like JK was this way?
Are they the same measure? Then yes. Okay, so your homework is from the book, but where do you find the book? Google Classroom. Aiden, before you come, what will you do with your answers?
Check
Check them. No, I just wanted him to tell you all. I'm not calling him out. No.